Today we are dealing about the kLEIN'S construction when the crank is rotating with uniform angular velocity, and this kLEIN'S construction is only applicable for the IC engine or the slider crank mechanism. I will consider one slider crank mechanism, and with the help of this one I will draw the velocity diagram and I will arrive some formulas. Exactly perpendicular for this one, I will draw one more line here. Direction I will provide this one. I will write it as a V C related to O here, and this is small c and O here, and exactly 90 degree for this line. A line is drawn. V P C, or it's a combination of V C P. We don't know which related to which here. And this is the fixed end. O is the fixed end. And piston always moves in horizontal direction. I will draw it in this way, and I will go for velocity V P O. And next, based on this one, I will go for velocity diagram. First, in this way, I will construct a diagram here. I will write as V C O, as the arrow indicate this side, C this side, and O this direction. And next, this one connecting rod, where C or P is known. Whether C or the P is known. Here the C is known. From the C, line is drawn. From the C, line is drawn in this way, which moves downward direction. Next, O and P. O is known. As O is known, from the O, line is drawn. It intersects at P. As it intersects at the P, we have to show the direction towards the P. This is the P in this direction, and this becomes V P C, and this becomes V P O. This is the velocity diagram, which is obtained with the help of this mechanism. Now, with the help of kLEIN'S construction, how it's going to operate? It is very simple. Just you have to draw a line perpendicular to this OP. You have to draw a line here perpendicular to OP here, and extend this line, and this line going to meet at M. This is the velocity diagram which is obtained with the help of kLEIN'S construction, and I will draw separately here. It is in this way. This is the O, this is the M, and this is the C. This is the C. Now, this OP is nothing but what? OP is nothing but act as a crank here, so piston. This CP is act as a connecting rod, and OC act as a crank here. Similarly, OM act as a piston here, OM piston here. This one act as a connecting rod, and this act as a crank. By similar triangle, I have to arrive formula. It is very simple. First, I will take this diagram and this diagram. First, OC divided by OC equal to, I will go for connecting rod, Cp or Pc divided by Cm next equal to piston OP divided by OM. Why I am taking in this direction? If you rotate this diagram in this way, it appears in this way. I am rotating this diagram now. This we will rotate this direction, it becomes P and this becomes C. If you go for similar triangle, you will arrive this expression. It is very simple. I will rotate this diagram. To the 90 degree. The two similar triangle will be obtained. By using these two similar triangle, the expression will be obtained. After getting this one, I will go for some constant. And this constant I will consider as a omega. And OC, instead of OC, I will write as this expression. VCO is equal to OC. Next, Cp is nothing but V. PC is equal to Cm. Next, OP, instead of OP, I will write as VPO is equal to OM. Is nothing but omega. If you separate this one, it will appear in this way. VCO is nothing but OC into omega, and this is nothing but OC is nothing but crank. Next, VPC is nothing but Cm into omega, connecting rod formula. Next, VPO is equal to OM into omega, piston. This is a piston. This is a piston. Suppose here, if they are given some distance x in the connecting rod, capital X. If this is a connecting rod, then our connecting rod in acceleration diagram will be this one, as per the KLEIN'S construction. I will take one more x dash here, x dash, and this distance can be found. I want to find out this distance. Normally this distance is they will provide it. I want to find out this distance here. It can be found with the help of this formula. It is very easy to find this one. It is very easy. See how to find it one. Cp divided by Cx. Cp divided by Cx is equal to Cm divided by Cx dash. Once you get this one, you can find out x dash directly here. In this way, Cx dash is nothing but Cm into Cx divided by Cp. You can find Cx dash. Sometimes they will ask the velocity to find here. It can be found with the help of dotted line. Just draw a dotted line from this point. You can find the velocity of this one. It can be found very easy. Velocity, it is Vx dash written as Vox dash into omega. This completes your first velocity as a velocity diagram by using the KLEIN'S construction. This is the derivation we have arrived at. Next, we are focusing upon the acceleration, how to draw the acceleration by using the KLEIN'S construction. Again, I will draw the same diagram here, and I will go for drawing the velocity acceleration diagram now. First I will draw velocity diagram here. This is the P, fixed end, O, this is C, omega is rotating in this direction, omega. Now, in acceleration, we are focusing about the tangential force and centripetal force or normal force. For this one, the normal force is towards this direction. I will write as AN CO, and exactly 90 degree to this one, this arrow, tangential force will be act. This is AT CO, but this will be 0 because omega is rotating constantly. Therefore, tangential force will be 0. Next, I will go for centripetal force towards this one. Why I have selected this direction, why not this direction, means because the velocity diagram is meeting at P here. Therefore, I have to select this point. And one more, tangential force. This is the normal force, AN PC, AN PC. And next, a tangent is drawn from this direction. I don't know the direction here, AT PC, and the slider always slides horizontally. Last expression, slider always will slide horizontally. It can be as A, this is O, A, P, O, APO. This is the normal which is obtained with the help of this slider mechanism. This is the acceleration diagram. Now we are drawing the acceleration diagram here. Now how to draw that one? First, I will consider the normal force. Just I am drawing roughly here because arrow is towards this one. AN, CO, the C this side and O direction this side. And next is about, because the tangential force will be 0, next I will go for this one. Either here P we know and C we know, but there are two P's here. One P is here, one more is P here, and one more is here. Therefore, I will consider as a P dash here. While drawing this one, I will consider as a P dash, or you can consider as X. It moves some distance. And this one is a normal AN, PC, P dash. Next, tangential has to be drawn. From this direction, I will go for tangential. This is the tangent, I will draw on it. This is AT, PC. And next is this horizontal force, horizontal direction. But I know O, from O, draw a horizontal which will meet at P here. Now I have to show the direction towards that of the P. But I don't know CP, connecting rod, CP. Therefore, from CP, draw a dotted line. This is a CP. This is A, PC or CP. This completes your acceleration diagram by using the slider crank mechanism. Now, by using the kLEIN'S construction, how we are going to arrive? Look here. First, draw a line. Then I will construct a crank here. Then I will complete this one. This is a piston. This is a P. Fixed end. O. And this is C. This is O. This is angle theta. Next, I have to go for velocity diagram construction here. For acceleration diagram, this is required. Just draw vertical line and extend this line. It touches this one portion. This I will consider as a M here. Now C as a circle, C as a center, M as a radius. Draw a circle. Next, PC 3/4 taken, cut an arc 3/4 3/4 this direction. Again from this point 3/4 3/4. You will get midpoint here. Midpoint and a midpoint. After getting the midpoint, draw a circle in this way. After completion, from this intersection of the circle, draw a line. And complete the, I will consider this as a K, and this is as a L, and this point as a N. Now, this is I will consider as a N here, this point. Now, this portion is nothing but acceleration diagram by using the kLEIN'S construction, this portion. And Cn is nothing but a connecting rod, similar to this one. First I will draw a simple diagram, and this is nothing but Q here. Q. OC, Q, N, O is nothing but here acceleration diagram. First I will draw that acceleration diagram here, simple diagram. It is appeared in this way. N, O, C and Q. And this diagram has to be similar to this one. I will draw in other paper, another page. Now first diagram is in this way. The second diagram I have to make in this way. It appears in this way now. Otherwise I will make it in this sheet only. I will draw the diagram here. It appears in this way, similar to this one. This will be the C, Q, N, O, and this will connecting rod. This is the connecting rod, and this will be your piston. Now, by using similar quadrilateral triangle, you have to arrive some expression. Triangle. Now first I will consider this one. OP is nothing but ON. And next OC is nothing but OC. Write in the small and capital letter. And next is CP dash is nothing but CQ. Next P dash P is nothing but QN. And last one more, CP is nothing but Cn is nothing but some constant. If it is an acceleration, I will consider as a constant as omega square, because in velocity I will consider as a omega. Instead of OP, I will write A PO. I will write A PO is nothing but OM, and OC AN CO can be written OC, CP dash AN PC is nothing but CQ, PP dash AT PC nothing but QN, CP A CP or PC can be written as Cn into omega square. If you write separately, you will arrive this expression. An CO is equal to omega square into OC. An PC is nothing but omega square into CQ. A TPC is nothing but omega square into QN. A PC is nothing but omega square into Cn, and AP is nothing but omega square into ON. And this is for acceleration of the piston. If suppose if some distance is given in the connecting rod, this is x, then I have to find, and some distance is given here, this is unknown one, x dash. It can be found by using this expression, Cp divided by Cx is equal to Cn divided by Cx dash. It can be written as Cx dash Cn into Cx divided by Cp. And if we want to find out the acceleration of this one, it can be found Ax is equal to Ox dash into omega square. Acceleration of this one. This completes your kLEIN'S construction. Thank you very much for listening.